And our third speaker, the last faculty speaker in this segment, and then we'll come to the policy panel, is Danielle Lee. Welcome, Danielle.
Hi. Okay. Hi, everyone. Thank you so much for having me. I'm going to talk a little bit about some work I'm doing, but before I do that, I want to talk about why I'm excited about generative AI and ML. And in particular, oftentimes when we think about living in a world where there's like a lot of technology is being adopted, we think about AI and ML as the latest wave of technology. So it's like technology and more technology. But I actually think that machine learning works in an importantly different way. And in particular, the way that traditional computers work is that we program them. We tell them what to do. So what we have is computers, they take inputs, X, so it could just be numbers, and we give it instructions, like add these numbers together, and it produces the output much more reliably and faster than a human would. And as a result, traditional computers are really good at tasks that involve instructions. So it's really good at doing clerical work, for example. And so when we've studied the economic impact of these new technologies, we found that it has replaced workers who do a lot of routine jobs, and that's had a lot of implications for how inequality has evolved in the economy, so on and so forth. But if we actually think about what machine learning does, it actually does something kind of fundamentally different, which is that instead of saying, here's X, and here's what I want you to do with it, and I'm going to highlight very specifically what I want you to do with it, I'm going to literally program the instructions down. What machine learning does is that it learns from examples. So it takes like combinations of inputs and outputs. So here is a set of X-rays, and here is whether or not the person had a brain hemorrhage, for instance. And I use that data, and I feed it into the machine. And the machine is not learning about what producing an output. The output example is already being provided. What it's kind of learning about is about understanding the relationship between the input and the output. And so at a fundamental level, the knowledge of how to do something in the instructions for tasks, they're no longer the inputs into a program. They're actually kind of the outputs. I give a lot of examples of people doing jobs, and then the machine is kind of learning how to do that job, trying to understand it. And so I think one of those sort of important questions when we think about ML and AI in the economy is, what's possible in a world where machines no longer need explicit instructions? And I think that dramatically expands the set of tasks that we can ask machines to perform. So AI tools are being used for reading legal documents, for coding software, things that traditionally have been done by people with a lot of experience, a lot of kind of subtle tacit knowledge. And there's sort of a growing set of studies suggesting that AI can outperform humans on average, and even humans above average. Okay. The other thing that I think is really interesting is that, as we all know, machine learning is trained on data. And in the world we live in, this training data is primarily generated by individual people who are doing their jobs. So I'm a software developer. It's looking at the code that I write. It's looking at whether this code works. I'm a doctor. I'm reading radiology charts. It's looking at my decisions. It's looking at whether these people actually have the condition that I'm diagnosing them for. And all of that data is sort of being generated, and it's being recorded. And as we all know, for anyone who's ever worked with someone, if you look at humans doing their jobs, there's a tremendous variation in that some people are good at their jobs, and some people are bad at their jobs. And so if we think about machine learning data, what we're doing is we're getting data on examples of people doing their jobs well, and people doing their jobs poorly. So when we analyze that data and try to think about the patterns that predict good outcomes versus the patterns that predict bad outcomes, what a lot of these tools are implicitly doing is that it's learning what the difference is between a good worker and a bad worker. And in particular, what are the behaviors and actions that characterize people who have successful outcomes and people who have unsuccessful outcomes. So I think what happens with generative AI is that it takes those patterns that we learn from the data and it embodies them as outputs that people actually sort of produce. And so in one way, you can think about generative AI as learning from data and understanding kind of what best practices are. So learning to predict what's a good outcome and actually producing what a good worker might actually say or do in a given situation. And I think that's very different from the way that we traditionally think about certain other kinds of computers working. Okay. So what we're going to do, this is a paper that I've written with Lindsay Raymond, who's a fabulous PhD student here, and Eric Brynjolfsson, who is an alumni of MIT, who's now at Stanford. And what we do is we study what happens when a generative AI tool is implemented in the workplace. What we're going to be looking at is technical customer support chat. So imagine being frustrated with some program you're working on. You chat with the representative about how to fix it. So it turns out that this is one of the top use cases for modern AI tools, in particular for generative AI tools. And the technology we're going to study is it's going to be a conversational support assistant. So you're talking with the agent, and you're still talking to a human being, but what they have behind the scenes is a machine that's reading the conversations and providing real-time suggestions for how to respond. And so what we're going to do is we're going to study the staggered rollout. So different people are going to get access to this technology at different times. It's going to allow us to sort of track before and after differences, controlling for lots of conflating factors. We're going to have information on 3 million conversations, and there's going to be sort of 3,000 people kind of in this natural experiment. So this is what it looks like in the background when you're talking to customer support. There's a customer support agent. This is the person they're having a conversation with. I know a little bit about how this person is doing, whether they have the premium plan or the free plan, how long they've been a customer, just notes on the customer. I have some notes I can take to myself. And then this is the queue of all the other people I might have to deal with. And so what this technology does is that this is the input where I can talk to the person. And right now, I have to come up with how to speak to that person. But what generative AI does is that it provides sort of suggestions for different things I can say, or links to information that might be relevant to the problem that they're talking about. So we study this tool. And one of the nice things about our study is that we can actually sort of observe the data without doing much statistical analysis to it. So the nice thing about working with customer service support is that we have pretty good measures of what constitutes a good job. So do you handle calls quickly? Do you resolve a lot of issues for a given hour of work? So this is issues resolved per hour. This is how long it takes for you to handle a given call. This is the number of chats. This is the share of conversations that are successfully resolved. And so if you look at in this conversation, this is an average call about 40 minutes. So these are kind of fairly complex calls. So the data come from customer service workers for a financial services firm. So the average customer here is a small business owner that's having problems with payroll or taxes or employee onboarding. And they're having pretty long, detailed conversations about how to solve this. So this is before access to the AI assistant, and this is afterward. So what you see is that resolutions per hour goes up a bunch, average handle time goes down, chats per hour goes up, and the share resolved goes up. So then we can also do sort of the statistics to it, where we kind of control for differences in individual workers that don't have to do with the technology, differences in time. So in April, there's like a lot of tax calls versus in September, there wouldn't be. And so what you see is that before the time that the AI tech assistant is adopted, it looks like people's resolutions per hour are pretty stable. So nothing's changing that much. And then when it's adopted, I start to resolve a lot more problems per hour. And then we can split this up and say, okay, this is the benefit to workers on average, but do different workers benefit differently? And so there's a bunch of results in the paper. I'll just show you a couple. This is what happens when we think about sort of splitting it based on skill. So before the AI assistant is implemented, I have your productivity records. I understand how often you successfully resolve calls, how long it takes for you to deal with calls. And so I split workers up based on whether or not they were good at their jobs to begin with. And so these are the people who were bad at their jobs, and these are the people who were good at their jobs. And this y-axis, what we're plotting here, is the estimated benefit of having access to the AI, like the additional benefit of this technology. And so you see here, oops, that's not a, how do I go backwards? Okay, backwards, there we go. So what you see here is that it's the workers who are sort of, I guess the least good at their jobs who benefit the most from this technology. So they actually see a 35% gain in their productivity as a result of having access to this tool. Meanwhile, over here, for the most sort of the best workers, and this is also true by tenure as well. So the newest workers benefit the most. The best and the most experienced workers don't. You actually basically see a zero effect. They don't really get anything from this technology. And in fact, I don't have this up here. We can look at quality measures, so customer satisfaction, whether or not the call is successfully resolved. And we'll see positive effects here. And actually, we'll see some negative effects for the best workers. And so we can also look at workers, dividing them not by their skill, but by their experience, how long they've been at the company. And so one way to think about the impact of AI is to sort of imagine this is what a career trajectory looks like. This is when you first enter the firm, and this is after you've been there for a few months. And this is your productivity. And so you see that, in the world, we get better at our jobs as we spend more time on the job. And you see it in this data. So these are people who never have access to the AI assistant. And these are people who always have access. So if you start off, when you first show up at the company, you have access to the AI assistant, you progress much more quickly. And so actually, by month 2, so a person with AI access who's been at the company for about 2 months does as well as someone who's actually been there for almost sort of 10 months, 9 months, a year. And then what we can also do is we can look at a different group. These are people who start off, the green line, people who start off and they don't have AI access. But they receive AI access at about 5 or 6 months in. So in the beginning, they look a lot like people who never had access. They're improving at the same rate. But once they have access, you see that their improvement kind of increases the trajectory. So they look a lot more like the trajectory of the people who always had access. And I think that that's actually really important to think about when we think about hiring, because in a lot of roles, if you read job listings, they'll say things like, must have X years of relevant experience. Because what they want is they want someone over here, around where the blue line is, and not someone down here. But in a world where workers actually have access to some AI assistants, these kinds of requirements might no longer be as relevant. And so I think that's something important to think about. And then lastly, I want to talk about, before I show this actually, I want to talk about learning. So if you think about Google Maps helps us get where we're going. Does it actually help us learn to be better drivers? So you can imagine what happens if you took your Google Maps away. Would you be good at getting to where you're going? Or are you so reliant on Google Maps that if you didn't have it, you wouldn't know what to do? So what we do is we look at scenarios in which there are software outages. So because of a bug, the system falls apart, and people who were formerly using the AI assistant no longer can use it. And we can think about what happens. And so there's a few graphs on this, but I'll just show you one set. This is what happens to people who are trying out AI recommendations. So this line here is before here, no one ever had access to the AI. Here, they've had access to the AI, but all I'm plotting is how quickly, so this is called average handle time, so lower is better, how long it takes them to deal with a call. This is what happens only during outage periods. So this is like, I have had access to the AI for 2 months now, but on this day when I show up at work, my AI assistant is not working because there's a software bug. And so what you see is that among the people who had been using AI in their early adoption, they sort of been engaging with this technology, when you take it away from them, you actually still see improvements in their productivity, so in decreases in their average handle time relative to their pre-AI baseline. But if you look at people who kind of do their own thing and they ignore the AI, you see that when the outage hits, they didn't have many improvements. There aren't that many changes. There's a sense that access and sort of engagement with the technology actually seems to sort of lead to some durable skills in our setting. Okay. And then let's talk about, so that was productivity. So that's good for the firm, but we also care about what's good for the worker. And so I want to show you a few results on the experience of work. So these are settings in which your anonymous encounters with customers who are stressed out about things like taxes and payroll. And I would imagine that there are some situations in which people bring their best selves, like when you're talking with people that you want to have be your clients. Talking to customer service is generally not a scenario in which you are bringing your best self to the interaction. And so if you look in our data, people get yelled at a lot. And so what we can also do is think about how does the impact of this technology change how customers are interacting with workers. And what we see here is that customers, we can measure the sentiment of the conversations. So customers start speaking to workers a lot more nicely, and this is coming from like a decrease in like swearing, yelling, and things like that. And they ask to speak to the manager less. So they have sort of more confidence that the person they're working with, first off, has the skills to resolve the job, and not, so they're not asking to be transferred elsewhere. And so there's some additional results in the research that sort of show that these effects are bigger for novice people. So if you're new at a job and you're not very good at it, having access to the AI assistant makes you a little bit better at your job. And if you're better at your job, people are going to be mad at you less. And so you spend less time getting yelled at. Okay? And so let me conclude. So these are actually a very positive set of results, right? So productivity goes up, experience of work goes up. We also have some data that attrition goes down. So I think one of the takeaways is that if we looked at, when we think about technology, there's always this sort of worry that it's going to harm workers. And I think that's actually been borne out a lot by previous waves of technology in which new technologies came and it made the rich richer and it made the poor poorer, and that led to various social problems, for instance. And this is an example in the case that generative AI need not be bad for workers or for inequality. And part of that, I think, has to do with the nature of how generative AI works. It works by example. It learns what makes people good at their job, and it shares that knowledge with workers who are less good at their job. So it helps workers get better at their job, and it closes the performance gap between high and low skill workers. So that's cool. But it's also complicated. So what's happening is that ML is learning from the behaviors of high-performing workers. So if you're good at your job, it used to be the case that the thing that makes us good at our jobs, some of it is a formula that we can tell other people, but some of it is just kind of like stuff that's inherent, and even if we wanted to train someone to be as good as you are, you're not able to do that. And so that skill kind of like is locked in the worker and is part of their productivity. But what happens in a world where there's sort of increasing digitization, increasing monitoring at work, increasing sort of data recording, is that as you go about doing your job and you're good at your job, you're leaving records of yourself through all your interactions. You're sort of leaving a digital trace of the skills that you bring to a job. And what ML does is that it takes all of that data and it sweeps it up and it reconstitutes a version of you. So if I was like a good contact center, call center employee, it used to be that was just inherent in me. But now, because all my interactions are recorded, a third-party company, can look at all that data and generate a version of me that can then be sent to other people. So my productivity becomes disembodied from me, and it can sort of be sold and moved around on the market. One of the things I want to note is that the best performing workers in our data are generating the examples that are training the data and training the model and making that model productive. They are not getting any productivity improvements from access to the model, and they're not being paid for their contributions to the model training. And I think that's an important thing to think about, sort of the changing notion of productivity. It used to be the case that my productivity is whether I resolved this worker's problem, but increasingly my productivity is that, plus the fact that that is now contributing to model training. And I think it's useful to think about how we pay people in reference to this new notion of productivity. And then lastly, the unknown. This is a medium-term study, so we don't know what's going to happen. It might be the case that now we can do these jobs faster. We're not going to need as many people, so we're not going to hire as many, and these jobs might get replaced. Another possibility is that customer service is no longer a thing to dread. So I might just call when I have a little problem. And as a result, the company might learn more about me, more about my preferences, and the whole job can expand and become a part of customer discovery. We don't actually know that, and I think those are really important questions that we should trace sort of going forward. All right, thanks.
Take one question just while we sit down.
Yeah, sure. One question. There.
So I'm glad you brought up this issue of kind of taking someone's productivity away from the human and making it generalized, and maybe they're not able to capitalize on that productivity. So do you have any suggestions on what that might look like? I mean, if this values tenure, it values skill in some ways, because it makes those gaps kind of come together. Is it about giving someone a bonus or a licensing agreement when they contribute to the model, or have you thought about what it might look like to monetize that for workers?
Yeah, it's interesting. I mean, I think this is a conversation that came up a lot during the writer's strike, because in some sense that was a conversation about residuals. And so I think it can be a policy of sort of like a technological policy about sort of tracking people's, sort of the value of people's data inputs, or it can be about sort of, in music, for instance, if I sample someone's work, I have to pay them for that. That's a more explicit form of connection. But I think I think a less controversial thing is to think about, can we build technologies that track people's inputs? And then I think a second question becomes then about policy. Even if it's not sort of explicitly paid for, are there things that we do to sort of recognize and address that?
Quick question. So if the less skilled workers do as good a job as a worker that has been there longer, do you compensate them the same way?
I mean, I think that's a good question. It depends on sort of what what sort of the philosophy of the firm is. The way that this company did it was you had a base rate, and then you had bonuses for your performance, so how many calls you resolved. Under that schedule, what happened is that the high-skilled workers' wages stayed the same, and the low-skilled workers' wages went up. To the extent that they were competing for the same bonus pool, it could be the case that high-skilled workers probably went down a little bit, and low-skilled workers sort of ate out of that pool. And I think different companies would have different philosophies about the extent to which we should reward tenure, loyalty, or the idea of, even if I don't want to reward tenure, I want to make people stay, and I want to give people the prospect of a career. So there's probably reasons why you want to pay people who've been there longer more that are independent of their productivity. But I think that makes it more challenging, because then there's more trade-offs. Okay. I think we're good on that. Thank you.
Thank you very much, Danielle.